So, theory of quadratic equations. So definition first of all of a quadratic equation, which you are familiar from your high school program. We are dealing with A, B, C real numbers or coefficients, and we know that the solution is minus B plus or minus
root B square minus 4AC by 2.
2A.
Yes, sir.
Okay, so the first important result is that, or theorem is that, a quadratic equation cannot have more than 2 roots. Proof by contradiction. If possible, let the quadratic equation have 3 different roots alpha, beta, gamma. Then since each of these values must satisfy the equation, we have this equation implies A alpha squared plus B alpha plus C equal to 0. And A gamma squared plus B gamma plus C equal to 0. from 1 and 3 by subtraction. Since alpha not equal to beta by hypothesis, then alpha minus beta is not equal to 0. So we can divide this expression by alpha minus beta throughout, and we get plus b equal to 0. Okay, did you copy so far?
Yes, sir.
Okay, so from 2 and 3, a into plus b equal to 0. So implies by the equation just proved and this one, by subtraction we get a into alpha minus gamma equal to 0. So we are already given a is not equal to 0. Then what does this mean? It implies alpha minus gamma equal to 0, which implies alpha equal to gamma. We are contradicting ourselves. So it means a quadratic equation cannot have three different roots, right?
Right, sir.
So it means that a quadratic equation has only two roots. It could be double root. Two roots could be same.
Yes, sir.
Next we come to the nature of roots, which you had learnt again in your high school program. The nature of roots is dependent on the discriminant delta equal to b squared minus 4ac. We will quickly review it. So are you taking notes?
Yes, sir.
Okay. Okay. Beta equal to
By 2.
not by 2, by 2a.
Yes, sir. That's what I said. By 2a.
Oh, okay. There is some muffled, there is some, it could be a clarity of reception here. That's all.
Possibly.
That's fine. If b squared minus 4 is c, the quantity implies alpha and beta are real and
Unequal.
unequal. Good. Then if b squared minus 4ac equal to 0 implies
Alpha and beta are real and equal.
real equal. So this is the case of double root.
Yes.
and the roots are alpha equal to beta equal to minus b by 2a. Third, if b squared minus 4ac is less than 0, meaning negative, alpha beta are what people call imaginary, or in fact the right term is complex and unequal. We will study this further in complex numbers. Fourth, if b squared minus 4ac is a perfect square, alpha and beta are rational and unequal. So we come to some problems. Example 1. Show that the equation cannot be satisfied by any real values of x. Proof. So what do we do here? Compare it with the standard equation: a equal to 2, b equal to minus 6, c equal to 7. So the discriminant is b squared minus 4ac equal to
minus 6 square minus 4 into 7 into 2
equal to minus 20. So the discriminant is negative, implies roots are complex numbers. So a very nice note is followed, is in the order note. You will understand this hopefully now or a little bit later. If we plot this, plot 2x squared minus 6x plus 7, it will not cut x-axis because there are no roots. Because what happens is that at x-axis, if a graph cuts x-axis, then at that point the x-coordinate is equal to 0. Sorry, the y-coordinate is equal to 0.
Yes, sir.
So here what we mean is that this is the function ax squared plus bx plus c. If y equal to 0 somewhere, those x coordinates are the solutions. But in this case, when the discriminant is negative, though these x's, the solutions, are complex, so the graph will not cut the x-axis.
Yes, sir.
We come to example 2. For what value of k will the equation have equal roots? So delta equal to b squared minus 4ac ought to be equal to 0. So b equal to minus 6, a equal to 3, c equal to k. So 36 minus 4 times 3 times k equal to 0. So 12k equal to 36. Therefore k equal to 3. Next, example 3. Show that the roots of the equation are rational. Proof. So here we compare with, first of all, the standard equation ax squared plus bx plus c equal to 0 implies minus 2p r squared. So if the roots are rational, then what? What does it mean about the discriminant? Has to be a perfect square, right?
Yes, sir.
So now we evaluate the discriminant, which seems a little bit complicated. Equal to 4 times q squared minus 2qr plus r squared 4 times q minus r whole squared.
Yes, sir, which is 2 into q minus r. Is the square of 2 into q minus r, sir.
Yeah, so it's a perfect square, implies the roots are rational. Next, we develop the theory a little bit further. So given quadratic equation ax squared plus bx plus c equal to 0, a not equal to 0, let 1 root alpha be alpha equal to minus b plus. Now note that alpha and beta is quite a generic universal notation for a quadratic equation. Alpha, beta. Any text that you see, whether it's an American, Australian, British, they will call it alpha and beta. That is what I mean. It's a universal notation.
Yes, sir.
Over 2a. So then if we add them, what do we observe? Alpha plus beta is equal to minus b by a. And then if we multiply them and carry out the calculation, alpha beta will be equal to c by a. This is the sum of roots, SUM sum of roots, equal to, this is product of roots equal to c by a. So if we write our quadratic equation as x squared plus b by a over x plus c by a equal to 0, a not equal to 0, then it means it is x squared minus sum of roots times x into x plus product of roots equal to 0. This is the equation. It means that if alpha and beta are given, we can construct the quadratic equation. It is simple. A numerical example will clarify it. Example, if 1 and 2 are roots of a quadratic equation, simple question is build the quadratic equation. What will you do? You will just say it is x minus 1 times x minus 2 equal to 0. Right? Implies x squared minus 1 plus 2 times x plus 1 times 2 equal to 0. This is the original quadratic equation. This is the sum of roots. Here is the product of roots. So that is what we have claimed here in the general theory, x squared minus sum of roots times x plus product equal to 0. Note, it gives the quadratic equation with the coefficient of x squared as 1. Please make a note of it, very very important. So in general what we do? In general, if I generalize the numerical example I gave, if alpha and beta are roots, what does it mean? It means x equal to alpha or x equal to beta. It means x minus alpha equal to 0 or x minus beta equal to 0. In other words, x minus alpha times x minus beta equal to 0 implies x squared minus alpha plus beta times x plus alpha beta equal to 0. This is nothing but x squared minus sum of roots. This is plus product of roots, right?
Yes, sir.
Okay, so that's nice, beautiful, cute little theory. You might be surprised that there are actually about 101 known uses of these simple things called quadratic equations. Uses in electronic circuits, even controls of machines, so on and so forth. Form the quadratic equation whose roots are 3 and minus 2. Solution x minus 3 times x minus 2 equal to 0. So x minus 3 times x plus 2 equal to 0, x squared minus x minus 6 equal to 0. Example 2. Form the equation whose roots are 2 plus root 3 and 2 minus root 3. These are surds. So it is, you could do it this way, x minus 2 plus root 3 times x minus 2 minus root 3 equal to 0. This seems a little bit cumbersome. Method 2 is sum of roots equal to 4, product of roots equal to 2 plus root 3 times 2 minus root 3 equal to 1. Although both are almost same, there is only a minute difference. X squared minus 4x plus 1 equal to 0. Okay?
Yes, sir.
Next, example 1. if alpha and beta are the roots of the equation, x squared minus px plus q equal to 0, find the value of number 1 alpha squared plus beta squared, number 2 alpha cube plus beta cube. Solution: x squared minus px plus q equal to 0 is the given quadratic equation. Compare with standard or the generic quadratic equation ax squared plus bx plus c equal to 0. Here a equal to 1, b equal to minus p, c equal to q. Okay.
Right.
So alpha plus beta is sum of roots is minus b by a equal to minus p minus of minus p by 1 equal to p. Alpha beta equal to c by a equal to q by 1 equal to q. So once again, if I rewrite for the sake of convenience, alpha plus beta is p, call this equation 1, alpha beta equal to q, call this equation 2. So how are we going to get alpha squared plus beta squared? We will square both sides of equation 1. Implies alpha plus beta whole squared equal to p squared. So alpha squared plus beta squared plus 2 alpha beta equal to p squared, and alpha squared plus beta squared, what is alpha beta? Q. So 2q equal to p squared. We are done. Alpha squared plus beta squared equal to p squared minus 2q. Next, second part, we want to find the value of or evaluate alpha cube plus beta cube. So what do we know? Again, alpha plus beta equal to p, alpha beta equal to q. Of course, we know alpha squared plus beta squared also from the previous derivation.
P square minus 2.
P squared minus 2q. Right. So alpha cube plus beta cube equal to alpha plus beta times alpha squared plus beta squared minus alpha beta equal to p times p squared minus 2q minus alpha beta. Okay.
Yes, sir.
So which we can simplify anyway. Equal to p times p squared minus
3q.
3q. Next we come to a nice classical standard question. Example: if alpha beta are the roots of the equation Lx squared plus mx plus n equal to 0, find the equation whose roots are alpha by beta and beta over alpha. So solution, the sum of roots equal to alpha by beta equal to alpha squared plus beta squared over alpha beta. So in other words, we have to find alpha and beta here, the sum of the roots of this particular equation given Lx squared plus mx plus n equal to 0. L is not equal to 0. Please note that. Write it explicitly so that you can control all the variables. So sum of roots is minus b by a and alpha beta equal to product c over a n over l.
Yes.
So now we find alpha squared plus beta squared equal to alpha plus beta whole squared minus 2 alpha beta equal to m squared by l squared minus 2n by l. So of course we substitute this here. We have to substitute it here. Over alpha beta. M squared minus 2nl over L squared times L over n. So equal to M squared minus 2nl by nl.
Yeah, that.
On the other hand, we know alpha beta. Okay.
Yes.
Now see, hold on. We want a new equation whose roots are not alpha beta, but alpha over beta and beta over alpha. We have found the sum of the roots of the new equation. It is this m squared minus 2nl over nl. And what is the product of roots of the new equation? I will write in
Alpha
different...
beta into beta alpha, which is 1.
It is 1. Good. So product of roots is 1. So here we have the equation x squared minus sum of roots m squared minus 2nl by nl times x plus 1 equal to 0. So nl not equal to 0, plus nl equal to 0. Okay?
Yes, sir.
Next, example, find the condition that the roots of the equation should be one equal in magnitude two equal in magnitude and opposite in sign. The second condition, the roots are reciprocals. We have to find the condition. Condition on what? There will be condition on A, B, C. Clearly, you will see it now. Solution. Given ax squared plus bx plus c equal to 0, a naught equal to 0, alpha plus beta is minus b by a, alpha beta equal to c over a. Now if this, we talk of the first case, we want the roots to be equal in magnitude but opposite in sign. So what will happen? So we take a numerical example straight away. If the two roots are, if one root is 2, another 2 is minus 2.
Yes.
So they are equal in magnitude and opposite in sign. So if such is the case, sum of roots
Equal 0.
is 0. So alpha plus beta equal to 0, which is equal to minus b over a. Of course, a is not equal to 0, which implies b equal to 0. This is the condition for the first case. Our second case is that the roots are reciprocal, so alpha equal to 1 over beta. So alpha beta equal to 1 implies 1 is equal to c over a, implies c equal to a. That's the condition on the coefficients for the roots to be reciprocals. We next come to the last example of this session. Find the relation which must subsist between the coefficients of the equation when one root is thrice the other.
1 second, sir. Let me just go get water.
Please start taking notes. But one root is thrice the other. So let beta be equal to 3 alpha. So 4 alpha equal to minus q by p, and alpha square is equal to r by p. So from this we get the condition. See, this gives us clearly alpha is minus q by 4p. So alpha squared equal to q squared by 4p squared, but it is equal to this, equal to r by p. Of course, given the quadratic equation px squared plus qx plus r, p not equal to 0 certainly. So it is in the denominator, it is not a problem. So q square p equal to 4p squared r. This then is the condition desired. This is the answer. We will next talk about the sign of the quadratic expression ax squared plus bx plus c, the sign sign.
Yes, sir.
It is a little bit involved. I would like to pick it up in the next session and continue with some tutorial examples of this small little theory that we have developed.
Yes, sir.
Okay, I'll see you tomorrow 7 o'clock.
Okay, sir.
Thank you. Bye bye.
Okay, bye, sir.